Hi everyone. In this video lecture, we plan to demonstrate the properties of region of convergence in Z domain. And as you all know, this is the second part where the first part is already put up inside our channel. Now, for the infinite duration sequences, causal, anticausal or non-causal sequences, let us see the properties of RoCs in Z domain. You know that the first equation represents a causal sequence, right-sided sequence. The second equation tells you about anti-causal sequence or left-sided sequence, whereas the third equation tells you about or illustrates non-causal or double-sided sequences. They are all given to you. Now we shall see the properties of RoC one after the other. Let the first case, x of n is equal to r1 power n, u of n is a sequence. You all know very well that r1 power n is a discrete power sequence, exponential sequence, and this is defined over only values of n greater than or equal to 0. Because r1 of n is accompanied with u of n. So n is greater than or equal to 0. Now, if you want to calculate the Z transform of this x of n, you know according to the formula that it should be written as n varies from minus infinity to plus infinity, x of n into z power minus n. But this will be defined, the sequence is defined only over the positive time axis. So I'll put it up like this: n varies from 0 to infinity. Yes, r1 power n, z power minus n. Yes, the given sequence is defined over the positive time axis. Now you know very clearly that inside this summation, n varies from 0 to infinity, these two powers, the terms can be combined like r1 z power minus 1 whole power n. It looks like a power n. As you all know, according to infinite summation geometric series summation formula, for n is equal to 0 to infinity, a power n will be written as 1 divided by 1 minus a, provided modulus of a must be less than 1 and it should be a value greater than 0. Right? So this is the condition to be satisfied. So using that one, I am trying to expand this x of z. What would be the expected answer? X of z will be written as x of z is equal to 1 divided by 1 minus r1 z power minus 1. Correct? You can recall what was the original x of z. X of z is equal to summation n varies from 0 to infinity r1 z power minus 1 whole power n, a power n. So that's how it is written like this. You know that this x of z can be even rewritten as 1 divided by 1 minus r1 z power minus 1 can be stated as z divided by z minus r1. Am I correct? Right. Any one of the formats would be useful for illustrating the infinite duration causal sequence and its Z transformation. And provided, you should remember what is the condition for infinite summation series. N varies from 0 to infinity, a power n is equal to 1 divided by 1 minus a, provided modulus of a must be less than 1 and it should be a value greater than 0. If the same condition is applied here, modulus of r1 z power minus 1 should be a value less than 1 and it should be a value greater than 0. Everybody knows that it is a value to be greater than 0, whereas it must be less than 1 also. So if you take this condition and if you start thinking about it, you can understand r1 z power minus 1 should be less than a value less than 1 will be stated as modulus of r1 divided by z. Modulus of z is less than 1. R in simple words, you can simply illustrate this as modulus of z should be a value greater than r1. What does it mean? This condition is actually represents a circle of radius r1. in Z plane, right? So I can tell you like this, I can pictorially represent the same condition in the form of a diagram. Just see this diagram, a circle with radius r1. Just imagine that this is a circle with radius r1, and you can notice that we are talking about the region outside the circle with the radius modulus of z. Modulus of z is greater than modulus of r1, correct? So the entire z plane is not available here as ROC. ROC of x of z, ROC of x of z, particularly for infinite duration causal sequence. This is the region exterior to the circle of radius r1 in Z plane. Exterior to a circle of radius modulus of z greater than r1, modulus of r1, right? Now you can notice that the circle of radius r1 in Z plane is marked like this. That's how we are representing it, exterior to the circle with the radius, right? So this is how the ROC is shown in the diagram. ROC. I'm ready to even show you the radius like this. I have an Z plane where U is taken in this axis, JV is taken in this axis. You know that Z plane will be a complex plane in which I am trying to take the radius, using which I am trying to plot a circle. I am trying to show the region exterior to the circle whose radius is r1. So I am planning to shade this region. Just imagine the shading is available like this. Shading, yes, shaded like this. Exterior. So x of z is equal to, what is x of z? X of z is equal to z divided by z minus r1, or this is 1 divided by 1 minus r1 z power minus 1. Agreed? So this is how it is written. When x of n is equal to r1 power n u of n, then its corresponding x of z is like this. Using with the ROC of this x of z is given like this. So please recall, if x of n is equal to r1 power n u of n, then its corresponding x of z is equal to 1 divided by 1 minus r1 z power minus 1, or the same one is rewritten as z divided by z minus r1. With ROC, r1 z power minus 1 is less than 1, or you should say that modulus of z is greater than r1, modulus of r1. So ROC, this is called ROC, the condition for the set of all values of z for which x of z will not become infinity, will converge to a finite value. This is the relationship to be remembered, and you should recall. How should you recall? Whenever you come across x of z, which is equal to, say for example, 1 divided by 1 minus 0.3 power minus 1 into z, or 0.3 divided by 0.3 minus ez, where ROC is modulus of z is less than modulus of 0.3, or modulus of z is less than 0.3. Okay. You will write this as x of n is equal to, through inverse z transformation, it is possible for you to state this as, how will you represent this? This is equal to 0.3 power n u of minus n, anti-causal sequence. This is called an anti-causal sequence. If you have clarity about this, there is a possibility for us to discuss further about non-causal sequences also. If you know x of z is equal to, for example, in this case, 0.3 divided by 0.3 minus z. If you know x of z is equal to z divided by z minus 0.3 and its RoC is region of convergence is the region of or the set of all values of z plotted on z plane for which x of z becomes non-infinity value. It is a finite value. RoC is modulus of z is greater than exterior to the circle with radius 0.3. The circle with radius 0.3. In such cases, because you know already that if x of z is equal to 1 divided by 1 minus 0.3 z power minus 1, then its corresponding where modulus of z is greater than 0.3, you will say x of n is equal to 0.3 power n into u of n, isn't it? So based on that theory, this must be the z transform of the sequence 0.3 power n 0.3 power n u of n, right? Similarly, I'll give you one more example. X of z is equal to z divided by z minus 0.7, where modulus of z is greater than 0.7 is its RoC. In such case, you can immediately write 0.7 power n u of n as its original time domain sequence. So because of applying z transformation on the given x of n sequence, it was possible for them to obtain x of z. The meaning, you can say that z transform of a sequence with 0.7 power n u of n will result in x of z is equal to 1 divided by 1 minus 0.7 power, right, 0.7 into z power minus 1. With RoC is the portion exterior to the circle where modulus of z is greater than 0.7 with the radius 0.7. Agreed? Second case, similar to this one. If we imagine a sequence which is completely of, say for example, infinite duration, but it is defined over only negative time axis u of minus n, only over negative time instances of time, or you would put it like this, r2 power n, where n is less than or equal to 0. In such cases, x of z will be equal to simply, how will you write this? In normal occasions, I used to put this as n is equal to minus infinity plus infinity, x of n into z power minus n. But in this case, you would know that it is defined only over negative time indices of time, right? So this will be defined from minus infinity to 0. Maximum value is 0 and it is defined up to minus infinity. So in that case, what is the expression? R2 power n, right? Otherwise, z power minus n will be present. So x of n is r2 power n and z power minus n is available. The summation is alone limited from minus infinity to 0. Or you can rewrite the same expression as n is equal to 0 to infinity. You have removed negative symbol from n, the values of n. So the penalty will be r2 power minus n and z power plus n. Agreed? If this is so, how will you write this expression? So x of z will become summation n varies from 0 to infinity in normal format, r2 power minus n and z power plus n. So the same thing can be expanded as summation n is equal to 0 to infinity r2 power minus 1 into z power 1 whole power n. You can combine them as usual according to infinite geometric series sum formula. Summation n varies from 0 to infinity. A power n can be written as 1 divided by 1 minus a, provided modulus of a must be less than 1 and it should be a value greater than 0 also. In that occasion, in that situation, x of z now can be rewritten as 1 divided by 1 minus r2 power minus 1 into z, right? X of z, correct? Or you can even rewrite the same expression as, how will you define this? This is equal to r2 divided by r2 minus z. Agreed? R2 divided by R2 minus Z. That and all we will discuss later. Let us see how to expand this. The condition is R2 power minus 1 EZ must be a value less than 1, and it should be a value obviously greater than 0. If in that occasion, in that situation, I just put it like this: modulus of R2 power minus 1 EZ whole is less than 1. Just analyze the condition alone. In this condition, you will understand one thing. What is it? Modulus of Z divided by modulus of R2 should be a value less than 1. Or modulus of Z less than modulus of R2 denotes the interior region of a circle with radius R2. So I can show you the RoC representation like this: the region interior to the circle with radius R2. So we can notice that the RoC is the region completely within this circle with radius R2. RoC is, right? It is actually, what is it? RoC is modulus of Z is less than modulus of R2, where R2 is the radius of the circle. R2 is the radius of the circle. You know very clearly that U will be taken in this axis and the imaginary part will be represented here. This is called Z plane. Z plane. What do you really understand from this kind of situations? I'll mention about it.